Hey guys, welcome back to the Kubernetes series. In the Kubernetes Architecture chapter of this series, we have learned that Kubernetes scheduler is responsible for scheduling pods onto nodes. But how does Kubernetes scheduler picks up the best node suitable for our pod? And is it possible to customize this behavior? In this section, we will learn how Kubernetes scheduler works, and also we will learn how we can customize this behavior using nodeName, nodeSelector, Affinity, Taints and Tolerations with complete hands-on. So without any further delay, let's get started. In real time, we will have so many nodes in the Kubernetes cluster, and when we create a pod, Kubernetes scheduler filters the nodes that can run this pod, and then it runs a set of functions to score the feasible nodes from 1 to 10. And finally, it picks a node with the highest score among the scored ones and updates the node name onto the pod. Kubernetes scheduler considers our pod resource requirements and other customizations defined by us while scheduling the pod. Most of the times, we do not need to guide the scheduler as it will automatically do a fabulous job for us. For example, running our pods across multiple nodes so that even if one node goes down, the pod on the other nodes can still serve the request. However, Kubernetes schedules the deleted pod onto a different node when we use deployments or stateful sets. But there may be cases where we want to deploy our pod onto specific nodes, like to deploy our pod on a node with SSD attached, or to deploy two pods in the same availability zone that communicate frequently. That's where we need to instruct Kubernetes scheduler. There are different ways with which we can instruct Kubernetes to schedule our pods onto specific nodes. Let us learn each one of them starting with nodeName. For hands-on, let's set up the Minikube cluster with 4 nodes. Minikube start -nodes 4. The cluster is created. Let's verify our nodes with kubectl get nodes. Awesome! We have our 4 nodes ready. These are the names of our nodes. Like this, every node in the cluster gets a name. And the simplest way to instruct Kubernetes to schedule our pod onto a specific node is using this node name. Let's see this in action. Let's create a simple deployment file. todo-ui-deployment.yaml. In the interest of time, I'm just pasting the manifest. If you want to know more detailed explanation on how a deployment works, please refer to the Kubernetes deployments chapter of this series. Now let's give the node name to this deployment so that our pods gets deployed to onto a specific node. So let's give the node name as minikube-yum02. Please note that the information related to scheduling will be at the pod level, not at the container level. So here we are instructing Kubernetes to deploy all our deployment replicas onto second node. Let's go to the terminal and apply the deployment. kubectl apply-f todo-ui deployment.yaml. As you can see, the deployment is created. Now let's try to list down the pods. kubectl get pods, and let's give the wide option to display the node names. As you can see, we have the 2 replicas, and the first replica is running on the second node, and second replica also running on the second node. If we would not have given the node name in the deployment, these 2 pods would have been deployed to 2 different nodes. But as we gave the node name, Kubernetes deployed our both replicas onto the same node. But it's not advisable to schedule all our replicas onto the same node for high availability. To run our pods on multiple nodes, we should use nodeSelector instead of nodeName. Just like we added labels to our pods and deployments so far, we can add labels to nodes also. Note that we can add any number of labels to a node, and same label can be added to any number of nodes. And in our pods or deployments manifest, we give the nodeSelector instead of giving the node name, like key value pair. In this example, team analytics. This way, scheduler picks up all the nodes matching this label and deploys the pods onto these nodes. So let's see this in action. We can add labels to nodes with kubectl label node and node name. Let's choose the first node whose name is minikube, and we should give the label in the form of key and value pairs. Team is equal to analytics. Enter. As you can see, we added the label to the first node. Let's add the same label to the third node, M03. Cool. Now we added the same label to the first and third nodes. We can verify the node labels with kubectl get nodes show labels. As you can see, these are all the labels of the first node and these are the labels of second node, etc. Please note that by default, Kubernetes adds the default labels for every node. For example, Kubernetes added this label saying that this node architecture is AMD 64. In the same way, the node OS is Linux and the node name is minikube-m02, etc. And this is the label that we added onto the first node and third node. Also, we can filter our nodes with specific labels. Example, kubectl get nodes -l team is equal to analytics. Now we got all the nodes which as the label team as analytics. So let's give this label as nodeSelector in our deployment file. Let's go back to our deployment and instead of node name, let's give the nodeSelector and the label as team analytics. Note that while adding label we gave equal to as the separator, but here we are giving as the colon. So let's go back to terminal and apply the changes. kubectl apply -f to do UI deployment.yaml. As you can see, our deployment is changed. Now let's try to list down the pods. kubectl get pods -o white. Did you see the difference? Now our pods are scheduled onto the first node and third node. This is because we have given the nodeSelector as team analytics and we have the first and third nodes with this label. nodeSelector is very simple and serves our need when we want to deploy our pods onto specific nodes. But it doesn't provide everything that we may need. For example, we can't get our job done when we want to run our pod onto a node which is having label value greater than 3 or onto a node which has a particular label. With the nodeSelector, we do not have the flexibility to provide these little complex conditions. Because of that, a more powerful mechanism was introduced, which is Affinity. In short, Affinity is an alternative to nodeSelector and allows us to instruct Kubernetes to schedule our pods onto specific nodes with advanced operators. Affinity is of two types, nodeAffinity and podAffinity. Let's look at both of them starting with nodeAffinity. Let's see this in action. So instead of nodeSelector, let's give the Affinity. And as I mentioned, Affinity is of two types. So let's start with nodeAffinity. And again, this nodeAffinity is of two types. The first one is required during scheduling, ignored during execution. Though this term looks difficult to read, it's very easy to understand. The labels that we are going to define in the nodeSelector terms are required during scheduling, but those are ignored during execution. Required during scheduling meaning whatever the labels we specify in the pod definition, the node must has the same labels during scheduling, or else the pod sits in the pending states. These labels are required. And ignored during execution meaning the pods which are already running on a node doesn't get impacted even if node doesn't have those labels. Indirectly we are saying not to disturb the running pods no matter what happens to the node labels. So now let's give the labels. We give the labels in the affinity with match expressions and we should give the key and value here. Key, let's give it as rank and value as less than, LT meaning less than, GT means greater than, in means it contains, not in means it doesn't contain, exist means if it is having a label, and does not exist meaning it chooses a node which does not have this label. So for this case, let's go with the less than and we give the value with values and the value I'm going to give it as 5. Cool, our affinity section is done. All we are saying is choose a node which is having a label key as rank and its value should be less than 5. So let's apply the changes, go back to terminal and apply the changes. As you can see, the pod is configured. So let's try to list down the pods. As you can see, the pod is sitting in the pending state. This is because we have given the label as rank, but we didn't add that label to any of the nodes. And also we mentioned required during scheduling, meaning these labels should exist on the node while scheduling the pod. So let's go and add these labels to the node. So kubectl label node mini q hyphen m02, and the label is rank and the value is 3. And let's add the same label to the third node and the value as 5. So now let's try to list down the pods. As you can see, now the pods are automatically running as soon as we added the label to a node, and both pods are scheduled onto the same node. This is because our match expression says that rank should be less than 5, but third node is having the rank as 5, which doesn't fit the criteria. And even if we delete these labels from the nodes, the pods won't be killed because we mentioned here as ignored during execution, meaning when the pods are executing, these labels are ignored. Instead of required, we can also have preferred, or we can have both required and preferred. Let's say we have 4 nodes with these labels. With preferred, we are making a preference among nodes. This is the typical example. Here we are saying that prefer nodes which has region US East 1 3 times more than the nodes which are having the label as team analytics. We give this preference with weight. So based on these preferences, Kubernetes ranks the nodes and chooses the nodes with the highest rank. Please note that this is not a hard rule like required. This is the soft rule, meaning even though the scheduler doesn't find the nodes with these labels, the pod gets deployed to on some other node. As I mentioned, this is just a preference. That is the reason the Kubernetes scheduler is ranking the 4th node also, even though it doesn't have any of the labels that pod is expecting. So let's see this in action. So in the interest of time, I pasted the preferences. Here we are saying that the first preference goes to the node which is having the rank greater than 4, and the second preference goes to the node which is having the label as team analytics. So let's apply this. As you can see, the deployment is updated. So let's list down the pods. kubectl get pods -o, as you can see, the pods are still on the same node. This is because first Kubernetes will look at these labels because these are required. So it will filter the label which are having the rank less than 5, meaning the second node. And then it applies these preferences in the filter nodes. And as there are no nodes matching these preferences, it will choose the second node. So let's try to delete this section and see what happens. Let's apply the change. It's configured. And now let's try to list down the pods. As you can see, our pods got deployed onto the third node. This is because we are giving the more preference to the nodes which are having the rank greater than 4, which is nothing but the third node. So this way we will have the more flexibility to define different conditions using the affinity. Please note that if we define both nodeAffinity and nodeSelector, both must be satisfied for the pod to be scheduled onto a node. And if we define multiple nodeSelector terms associated with the nodeAffinity, then the pod can be scheduled onto a node if one of the specified nodeSelector terms can be satisfied. And if we define multiple match expressions associated with a single nodeSelector term, then the pod can be scheduled onto a node only if all match expressions are satisfied. And as we discussed, affinity is of 2 types. We discussed about the nodeAffinity. Now let's discuss about the podAffinity. We learned that nodeAffinity is used to schedule pods onto nodes, but podAffinity is used to co-locate the pods. Imagine a case where we want to deploy 2 applications which communicate frequently in the same region. That way the latency will be less. That is where podAffinity helps. For a very simple example, let's consider our To-Do UI and To-Do API applications. Imagine that our UI application is deployed onto a node in the US East 1 region. Now we want to deploy our API application also in the same region. For that, we should define the pod affinity. Here we are giving the label selector and extra topology key. What Kubernetes scheduler does is, it gets the pods with the label selector and gets the value of the topology key and runs our new pod onto a node with this label. So that way both UI and API applications are in the same region. They are co-located. With pod affinity, we co-located the pods. In contrast to it, there might be cases where we want to keep our pods away from each other so they don't disturb each other's performance. In other words, we are forcing the scheduler to spread our pods across different nodes or availability zones or regions. That way, a failure of the node never brings the complete services down. Let's see this in action. For that, let's create a API deployment to do API deployment.yaml and paste in the manifest in the interest of time. Here we define the pod affinity under the affinity section similar to the node affinity. The pod affinity can also be two types, soft and hard. So let's go with the hard route. So here we are saying that choose the pods which are having the todo-ui label and then the topology key as the host name, meaning the node name. So the expectation is that these pods should get deployed onto the same node because we define the topology key as the host name where the UI application is deployed because we define the UI pod labels. So let's apply this. kubectl apply -f to do -api deployment.yaml. Oops, there is some error. This should be inside the spec, so it's an indentation problem. So let's try to apply again. Cool. The API pods also created. So let's try to list down the pods. As you can see, the API pods also deployed onto the same node where UI pods are deployed. So this is how we co-locate the pods onto the same node or in the same availability zone or in the same region. So let's look at the pod anti-affinity. For that, all we need to do is pod anti-affinity. So now we are saying that get the pods which are matching this label, which is the UI pod, and get the value of this topology key, which is the host name. And with anti-affinity, we are saying do not co-locate the pods. So with this, the expectation is that the API pod should never get scheduled onto the same node because we define the topology key as the host name where our UI pods are deployed because we gave the match expression as the UI pod labels. So let's apply this. It's updated. So let's list down the pods. kubectl get pods right. As you can see, the API pods are deployed to the node 2 and node 4, but not to the node 3 because we use the pod anti-affinity. We understood that affinity attracts the pods to certain nodes. There will be cases where we need quite opposite to this, that is to keep pods away from certain nodes. We can achieve this with taints and tolerations. Let us try to understand this concept with a simple analogy. Assume Bob applied mosquito repellent to keep away mosquitoes. It means his body is tainted with mosquito repellent. As mosquito cannot tolerate this repellent or taint, it cannot bite him and will fly away. So the body here is the node which is tainted and mosquito is pod which is non-tolerant. However, if another type of bug which is tolerant to the applied taint comes, it will be able to sit on his body. So in this case, the body is tainted and the other bug is tolerant. So as a summary, if we compare the Bob as a node and the bugs are the pods, with taints and tolerations, we can keep pods away from nodes and attracts only pods which are tolerant. So we can add a taint to the node with kubectl taint node and node name and the taint value. Environment is equal to production and the taint effect. There are three types of taint effects. The first one is no schedule, which is a hard rule. When we specify this taint effect, we are saying that Do not schedule the pods onto this node if the pods cannot tolerate this thing. And the second one is prefer no schedule. This is a soft rule. Here we are saying that the pods can be scheduled if no other nodes are available, even if the pods can't tolerate this thing. And the last one is no execute, which is very strict. With this, we are saying that delete even running pods if they cannot tolerate newly added thing. First, let's list down the pods, and we can taint a node with kubectl taint node, and let's taint the second node, and the taint is environment is equal to production colon and taint effect. So now let's give the taint effect as no execute. Enter. So now we added this taint to the second node. So now the expectation is, as we define the no execute taint effect, the pods which are already running on the second node should be killed. So let's verify that by listing down the pods. As you can see, the pod which was running on the second node is terminated and it is getting created on a different node, because this pod cannot tolerate the taint that we defined. And as we define the taint effect as no execute, it will be applied on the running pods also. If you want to look at the taints that are applied onto a node, we should describe the node. kubectl describe node and node name. And these are the taints applied onto the node. We can delete a taint from node by just adding a hyphen here. So now the node is untainted, meaning the taint is deleted. So let's add the taint with a different effect now. No schedule. Please note that a taint is added to the node and toleration is added to the pod. So before applying the toleration, let's try to add the node affinity so that it gets deployed onto the second node. So now let's apply this change. The deployment is updated. Let's try to list down the pods. As you can see, the pod stuck in the pending state, and nothing happened to the existing pods because the taint effect we mentioned as the no schedule. No schedule taint effect works only during the scheduling. It doesn't impact the running pods. As you can see, the pod stuck in the pending state. This is because when we mention the node affinity which is having the rank less than 5, the scheduler tried to choose the second node which matches that criteria, but as we applied the taint onto that node and the pod doesn't tolerate the taint, the pod stuck in the pending state. So to make this pod run, this pod must tolerate the taint that we added. So we can add the toleration with tolerations key value and taint effect. So this matches the taint that we added. So let's apply the change and try to list down the pods. As you can see, now the pods are running on the second node because now the pods are tolerant to the applied taints. And finally, the last taint effect is the prefer no schedule, which means that if Kubernetes cannot find any other nodes for the pods to schedule, it can schedule the pods onto this node. This is a soft rule. You can try this as your homework. So let's summarize what we learned. The simplest way to deploy a pod onto a node is with nodeName. And if we want to choose nodes for our pods with labels, then we use nodeSelector. And for advanced options like exist, greater than, less than, we use Affinity. The affinity can be soft or hard. In Affinity, we have the nodeAffinity, which is used to choose specific nodes with these advanced operators. And podAffinity is used to make the scheduler to deploy pods to the same nodes where another pod is running based on the pod's label and topology key. Pod anti-affinity can be used to keep certain pods away from each other, and a taint can be added to a node. There are 3 types of taints exist. No schedule completely prevents the scheduling. Prefer no schedule is a soft rule which is defined to schedule the pods onto this node if no other nodes are available. And finally, no execute taint effect evicts even running pods from a node. And pods won't be scheduled to that node unless they tolerate the taint. That's it for this section. I hope you found it helpful. My name is Pavan Elthepu and I thank you very much for watching this video. If you liked it, please share it with your friends and do not forget to subscribe to my channel to not miss any updates.